Hello everyone. The topics for today's presentation is curved displays. I'm Arpita Jaina and together with my team members Prince Singh, Ume Kulsum and Akshay Jaiswal, we'll be guiding you through this intriguing topic. So, basically, what are curved displays and why do we need it? So, curved displays refers to screens that are gently bent outwards instead of being entirely flat. These screens are designed to mimic the natural curvature of the human eye or to create a more immersive viewing experience. So, next up, we'll be talking about its advantages, and Prince will guide you through.
All right, so talking about some advantages of curved display. Firstly, we have a wider field of view. So naturally, we have a curved like vision. We can see all around us. It's just not a flat screen. So the curved displays try to mimic that, a natural human vision. And secondly, we have improved depth perception. The curvature contributes to a sense of depth, making the content appear more 3D like. Third, we have less distortion. About this, we'll talk further in the next slide. And lastly, we have potential viewing comfort. So certain users have reported that they have reduced eye strain as the curvature of the screen can better match the natural shape of the eyes. So that potentially leads to increased comfort during extended viewing sessions. Moving forward, we have this R rating and the reduced distortion thing. So what does this R rating of a curved screen means is, if you'll extend our screen in both the directions, it will complete a full circle. The radius of that circle is the R rating in millimeters. So for example, here is a 2300 R rated screen. And this curved screen allows, this is also the maximum recommended viewing distance, which is equal to the monitor curvature in millimeters. And this curved screen allows to reduce the distortion. As you can see in the flat screen besides it, the distortion at the edges can lose some quality in the picture. So curved displays also tries to focus this. Next, we'll move forward to disadvantages as we both have trade-offs here. So Akshat will continue to disadvantages.
Okay, coming to the first disadvantage, limited viewing angles. Curved screen suffers from reduced picture quality, and when seen from different angles, they appear to be distorted. The display and diminishing viewing experience, in especially in group settings. The second point, space and mounting challenges. Due to their shape, curved display can be very less efficient in terms of space and mounting, restricting the versatilities of placement compared to flat screens. Glare issues. The curved design and larger surface area attracts more light and causing more glare, presenting a significant challenge, especially in well lit environments. Now, coming to the point of the cost, potential higher cost, curved display often comes with a heftier price tag as compared to the flat screen because of the complex manufacturing processes they come through. Now, Arpita will explain thermoforming.
So basically, thermoforming plays a crucial role in manufacturing curved displays, mainly because it's flexible and cost-effective way to create plastic into complex and curved forms. So now, what is this process all about? So this process is perfect for creating consistent and precise curvature needed in modern curved screens like we see in TVs and monitors nowadays. It heats the plastic until it's malleable and then molds it into a desired shape, ensuring that it is uniform across all the units. So besides being budget friendly, so thermoformed parts are basically very lightweight and still they are very durable, so making them ideal for such displays. So the method not only meets the technical demands of curved display production but also contributes to the like sleek and modern aesthetics that we want in the curved displays of modern day devices. So this process is really useful and cost effective, and it's used in a lot of industries nowadays to make all sort of things like packaging, car parts, household items, and even used to make medical devices. It's used for making complex shapes and designs pretty easily. And moving forward, we'll be talking about LCD, and Ume Kulsum will talk more about it.
So yes, I'll be discussing the core components and functionalities of LCDs. LCDs are liquid crystal displays that utilizes liquid crystals, which are unique molecules responsive to electric currents, capable of aligning in particular configuration. These liquid crystals are positioned between polarizing filters that selectively permit or obstruct light waves according to their orientation. Complementing this setup is the backlight, that is commonly composed of LEDs, that is light emitting diodes, which furnishes the illumination essential for the screen functionality. Now, how an LCD operates? An LCD operates through the manipulation of liquid crystals housed between two polarizing filters. When an electric current is applied to specific areas of the liquid crystal, it alters the alignment of the liquid crystals. By changing their orientation, the liquid crystals either allow the light to pass through it or just block it. Polarizing filters aid in the controlling of light direction that pass through the liquid crystals. This manipulation of light forms pixels, with each pixel composing of 3 subpixels for red, green, and blue. By adjusting the intensity of these colored subpixels, the screen generates a spectrum of colors. A backlight, often made of LEDs, illuminates the liquid crystal layer, enabling the creation of visible images by modulating the passage of light through the aligned crystals, resulting in the vibrant display seen on the LCD screens. So this is how LCD functions. So this was the topic discussed in our presentation. Very much thank you for attending it.